All right. Cool. Just getting everything set up here. All right, welcome to Study Hall. Hope everybody's doing good, having a good day. Just want to give a heads up. This is going to be the last study hall for this week. I'm going to not have a study hall on Friday, and the next study hall will actually be a week from today. It'll be next Wednesday. We're going to skip Friday and Monday, since Monday is a holiday. So yeah, hopefully everybody's doing well. I think I already said that part, but you know, still stands. And yeah, if you're new, welcome. This is Study Hall. This is a place for you all to come and bring your questions, especially from Learn. If you have questions from other places, you can bring those in as well. I do want to keep things constrained in my streams to sort of beginner and intermediate Python topics oriented around getting people through the technical interview. So yeah, feel free to put in your questions with a link to the problem that you're looking at solving, a link to that in Learn. And I'll go through them. And if you have any other, like, you know, if you're wanting to explore a certain concept, or if you're, you know, thinking about the problem in a certain way, you know, any kind of question that you might have in that regard, feel free to bring it in. And yeah, so I don't see any questions at the moment, so we're just going to go through the material. So last time we left off on variables. We were just talking a little bit about variables. And I kind of just given a simple example of a variable a equals 10 or whatever. So here we have a variable, and it's worth kind of knowing what the parts are, right? So a is the identifier, equals is the assignment, operator. Sorry. That'll be your assignment operator. And then 10 is the value. So this is the assignment operator is directional, if you will, right? Like we can only, you know, you might be familiar, and you're probably familiar in, you know, in math, you can say like 10 equals a, and a equals 10, and these are equivalent expressions. In Python, we have to have the identifier, the assignment operator, then the value in that order. So we can't do it in the opposite order, even though it's, you know, that would be a logical statement in other domains. So yeah, the assignment operator often gets confused with, and I'm guilty of this, I'm guilty of calling it equals, because it is the equals symbol, right? It's the same symbol that we think of as an equals symbol, but this operator is meant to assign a value on the right to an identifier on the left. So it takes this value and it gives it this name, basically. And that's all it does. This is not to be confused with the not the equality operator, which is double equals like this, right? So if you want to see if two things are equal, you know, you could do 10 equals 10, and this is going to give you true or false. This is what we call an equality, the equality operator. And this is going to give us, you can see true down here. If I run this again, true. We can say 20 equals 10. Obviously, that's going to be false. So this is the operator that we use for checking equality. And the way we think about equality, or an equality check, or checking equality in Python, is it's a question that is either true or false. We're asking, is the thing on the left equal to the thing on the right? Not make the thing on the left have the value of the thing on the right, which is assignment. Cool. Okay. So let's just look through this. So a variable is simply a name that you use to reference a value stored in your program's memory so that you can reuse them later. You can assign any data type to a variable. See this REPL, there's an example, and you can go in and run the code there. So there's this idea of being able to reuse things. So imagine you have like a, I'll just make something up here. You have some expression, I'll leave that, sorry. You have some expression in your project that you're working on in your program that's kind of long, like how should I do this? I'm just trying to think of a longer expression. We could say imagine we had a factorial function. And then we could say, this will actually be K. I'll do this. Like 1 over, this is a combinations algorithm, and then we could do to the power P or something like that. So let's say I have to do this operation, and of course we would have essentially variables n equals 10 and k equals, we could say 7, and p we'll say equals 0.5. And let's say I just have some longish operation. I might not want to like write this out every time I want to use it. I might just want to say like res. And then, oops. Next time I want to use it, I can just say res. And I can use res as many times as I want in my code, and res is often res is short for result. That's why I use that. It's just a common abbreviation. So I can use that simple variable name rather than typing this whole big thing out every single time. Let's see. I was trying to write out this. There we go. Oops. There we go. So this is actually our binomial PMF, and of course we're lacking a factorial function in this. It's not defined, but this would be a way we could write out a whole binomial PMF. So we could just call this the PMF, probability mass function for a binomial distribution. We have these values in P and K, right? So you could see it's easier to write PMF next time you want to reference whatever this value is, rather than write this whole thing out every single time. So variables, they're useful, they're good. They're very good for you. Okay. Another thing is every time you call a function, you're asking Python to do a little work and like perform some process. Whereas if I wanted, and with, with a simple function that, where that work is pretty low, you can just call that function wherever. But if that function may have to perform like a lot of work, like a sorting operation is kind of a heavy operation. So this is actually another good example. Let's do this. Let's say sorted. And let's say we have a, let's do this. I'm going to import random, and I'm going to make a list. I want to say for I in range 200. We don't even need to do this. For blank in range 200, list equals empty list, and I'll just say list dot append. So I'm just building up this list. List append random dot choice, and we'll give it a choice of range 1000. So it's just going to choose a random number between 0 and 999 and append it to the list. So if I print list, I'm going to get 200 just randomly chosen digits. So let's just expand that a little bit so we can see the whole thing. So here's 200 randomly chosen digits. So if I wanted to sort this, I'm not exactly sure which. There's a lot of sorting algorithms that that exist, and I'm not exactly sure which one Python uses in its sorted function. I believe it has like a few different algorithms implemented, and it will choose one based on a number of factors that it thinks will be the most efficient. So I think it's a fairly well optimized function. And I'll just comment this stuff out for now. So if you see what I did here is I just copied this list so I don't get a completely different one every single time. Yeah, that way it'll just be the same list, and we can kind of work with something that's consistent this way. So we'll just do this, and let's sort it. So you can imagine the sorting operation is a little bit heavy. Even if it's well optimized, a sorting algorithm is still a fairly heavy operation. And this is, if I had to sort this list, I would probably only want to do it once. I'd probably want to just do it as few times as I could get away with, right? So if I had to use this sorted list in multiple places in my code, I probably wouldn't want to sort the list every single time. I'd probably want to sort it once and maybe store it in a variable called sorted list equals sorted list. And then we could do sorted list. And then this gives me a snapshot of what that sorted list is. It saves the whole thing in memory, and then I can use it as many times as I want, and Python doesn't have to go through the whole sorting process again. So there's a little bit of a trade-off here. If I make it into a variable, I commit it to my program's memory, which means it's going to stay in the memory as long. It's going to be written to memory. It's going to stay there as long as that variable is in scope. So if that variable is going to be in scope for a long time, and this list was very, very large, right? Like if it was 1,000,000 records or something, if it was 1,000,000 elements, then that's starting to cause potentially a pretty big memory footprint. So you may have to consider that, but in general, for even a large size object, it's probably worth a bit of a memory footprint to save yourself having to do a heavy operation multiple times. So if you knew in your code you were only going to use that sorted list once, then you could just use the function in place, just directly there, and you wouldn't need a variable. But if you thought you might need to use it multiple times, it's probably better to save it in a variable. So cool. All right. So this is just, I guess this is just about declaring variables. Naming variables. Oh. Let's just see here. You know what? I think we can just skip through the stuff on variables and get into something else. Oh wait, let's see here. Declaring variables. So we talked about declaring variables. There is something useful here actually to discuss. We can assign multiple variables in a sequence like this. We can do A, B, C equals, let's just say 33, 22, 55. And A is going to have the value 33, B is going to have the value 22, and C will be 55. So if I print A, B, C, 33, 22, 55. We'll just play around with it. So this is called unpacking. This data structure on the right-hand side is it's a data structure. It's called a tuple. And you'll usually see tuples surrounded in parentheses. Sometimes in this particular case, you will see them without parentheses, but Python will look at this and understand it as a tuple. With a tuple, or what I showed up here, this is a list. If you know how many elements are going to be in that object at the time that you're writing the code, you can unpack that object into the same number of variable names, right? So in this case, if I had, let's do something like this, my tuple, whoops, my tuple equals this. So if I had this object and I know there's 3 elements in it, I can unpack it into each individual variable names. And of course, these don't need to be A, B, and C. These could be foo, shmoo, and boo. So yeah, these can be any names that we want to give them. So one thing about this, you will see this kind of syntax used occasionally. It's really useful when you have something like a tuple or a list, and you want to pull it apart into its constituent elements. That's a really good time to use this. What I would encourage you to avoid is like declaring multiple variables on one line by default, or just sort of like as a matter of practice, or out of a, how would I say this? Like as a stylistic choice or whatever. Like you're like, if you were gonna just take this on as like a part of like your coding style, I would discourage that, because this kind of thing can get confusing. It can actually, you're saving yourself lines, but you're writing denser and denser lines. Where this is useful is when you have something that's already like basically a tuple that's already built up, and you're like, oh, I know there's 3 things in this tuple, so I want to unbox those things into their own elements for my convenience, and then that's when this is really useful. So it's important to know that it exists, but you don't have to do things this way. In general, if I wanted to make these variables, I would do something more like let's say let's see if this is gonna work. Huh. Oops, not what I wanted to do. And then, oops. Okay, there we go. Shuffled them together. That was way longer than just writing them out. Okay, so A equals 33, B equals 2, and C equals 55. In general, this is the convention, and you can see that this is just 3 very simple lines of code rather than one, not terribly complicated, but one line of code that, like if this was 6 or 8 variables long, it could be kind of messy. So things can get a little messy this way, whereas this is just kind of straightforward and easy. Okay. So this is another cool one. When you want to initialize multiple variables to the same value. So let's say I have multiple variables like that I want to use as counters. So let's say counter 1 and counter 2 and counter 3 equals 0. Oops, I gotta do this. It'll be like that. So let's just say, I'll just say for I in range, we'll make a little for loop, and let's just do 100, and we'll say if I mod three equals 0, then we'll counter 1 plus gets 1, and then let's do something like if I mod 15, we'll do that one for counter 2, and if I mod, let's just do 5. 3 to, okay, and now let's just print counter 1, 2, 3, 2, 3. Good. Okay, so this tells me that there was 34 numbers in this range that were divisible by 3. There was 7 that were divisible by 15, and there was 20 divisible by 5. Right. So, and let's do a sort of a before and after of this. I'll print out the counters before. You can see they're all initialized to 0, 0, 0, 0, and then 34, 7, and 20. Let's see if I can do this. And then this will be like that. So at this point, we've got the counters initialized to 0. They're all 0. Then we run some little process. Perform some process, and then we have our final value for our little counters. Okay. Let's just go through these challenges. So what is the value of x after the following variable assignment? So I can see x is from the left 1, 2, 3, 4th. So let's see 1, 2, 3, and this is the 4th element. So it'll be the string of 93.8. So, oh, hello. 93.8. That sounds like a radio station. Probably is. Okay. Which of the following is not valid syntax for assigning a value to a variable? X equals A, B, C. So this will create a tuple of A, B, and C, and it'll assign that tuple to X. So presuming A, B, and C have values, this is valid. A, B, and C equals X. Well, if X is a tuple, say from A, B, and C up here, then this will work. This will deconstruct that tuple. X equals 10, that's valid. X, Y, Z equals 1, 2, 3. And then A, B, and C equals 0. So this one is not valid. It's kind of unclear what's meant to be happening here because, you know, what's the intent of this line? I think presumably A, B, and C were meant to be all initialized at 0, but in order to do that, we can't use commas. If we want A, B, and C to be all initialized to 0, we have to say, A equals B, B equals C, C equals 0. So A equals B equals C equals 0. So this will initialize all of them together. Whereas if we did commas, this is not, initializing multiple variables to the same object. It's trying to unpack something, and there's only one thing there. So let's check the answer. I mean, it's right, but Okay, how should A, comma B, comma C be rewritten? Well, I guess I spoiled that one. So that's A equals B equals C equals 0. Meh. Oh, okay, so okay. It's interesting because my assumption was that, this line of code looks like it's meant to be initializing all three of these to 0, and either of these lines will actually do that. But if I'm thinking about like starting multiple variables at the same value, this is the syntax that I think of. Whereas if I think about, I have something with multiple elements in it, like a tuple or a list, and I want to unpack it, this is what I think of. So I'm sticking with my answer, even though it's technically wrong here. And then, yeah, we'll do it their way. Oh wait, either of the above. Oh, okay. I see. Okay, I should have read all the answers. Either of the above. Yes, they're both correct. Ugh. So that's what you've learned today. That's what I've learned today. Read all the answers for the multiple choice question. Okay. Cool. So naming variables. This is just going to talk about naming convention in Python, kind of best practices. So it's common to want to name a variable with like multiple words. You'll see me use some shorthand sometimes. You'll see me make some abbreviations like LST or TXT for a string or for text, and LST for a list, DCT or D for a dictionary, num for a number, I for an integer, things like that. So you'll see me make do a little bit of shorthand. You don't have to keep your variable names super short or anything. There are there are kind of old school standards of programming that emphasize really short variable names. Once upon a time, like back in the days of programming on punch cards, the punch card was only so wide, so you had to keep your variable names really short so that you didn't fill up the card. But today we don't have that problem. A line of code can be as long, excuse me, can be as long as you need it to be. Oops, let me sorry, I just realized my audio is peaking quite a bit. Let me turn that gain down a little bit. Hopefully that'll be better. Where was I? Oh yeah, so variable naming convention. So it's common to want to give your variables a good descriptive name and use multiple words. So if I wanted to call some variable name equals some value. So this is just a string. So we have some variable name equals some value. There are multiple conventions around this. You might be familiar with camel casing or Pascal casing or something like that. Python, you can do those. Camel and Pascal case are fine in Python. You can't do, you can't do kebab case. You might be coming from JavaScript or another language where you can do kebab case like this. You can't do that in Python. So the convention is to use underscores to separate words. And it can be maybe a little funny looking, but it just makes things clear and kind of simulates a space. If I tried to put an actual space here, I'd get an error. Python would see that as invalid syntax. So, yeah. Cool. Okay. Looks like we've got some more challenges here. Okay, so which of the following would be an appropriate name for the mean of mean height of adult men in the U.S.? Mean of heights for adult males in the U.S. I'm gonna guess it's this one, but it could totally be this one. It depends on your preference, but this is a very long name. Okay, we'll do this. So this would be probably what I'd be predisposed to do. To say like mean height male US. And then let's look at this. Is this an example of good naming convention? I'm going to say no, because this is just difficult to read. Like A does not. Well, A might be inappropriate. Single letter variable names generally it's kind of okay to just avoid them in principle. I'll use them for like numbers. When I use a single letter variable name, to me it's like it feels like I'm doing algebra, so unless there's a really good or obvious reason to assign it to something else. I think the exception to that I do often is if I'm naming a dictionary, I'll often just call it D, just the letter D. And so sometimes there are standing conventions around using a single letter variable name. In that case, it's fine. In this case, it might be fine, but this is code without context, so it has no case really. But yeah, AA for hello world, AAA for a list, and then this is IA5EWG15 underscore AWOD equals A dot append a triple A dot append single A, and this is just going to be none anyway, so that's just garbage. So this is not good naming convention. No, absolutely not. More like absolutely not. These variable names aren't even remotely descriptive. Which is better example of good variable names? So these are for loops. We're pretty early on in the material, so I'm not sure for loops have been introduced yet, but these for loops, in a for loop, we have the opportunity to name to essentially variables, or I'll usually call them identifiers because it's like the name part of a variable, and the way they get their values is from the thing being iterated over in the for loops, right? So when we're enumerating, enumeration gives us back the element that from the object that we're enumerating, from the collection that we're enumerating, as well as a number, basically the index of that object. So a counter next to that object that tells us whether it's the first or the 10th or the nth value in that list or whatever. So we usually think of that as an index, and then we think of the other one as a value or an element. So for IDX and val, if I say for I and v and enumerate, I will use either of these conventions, and I actually don't prefer one. In my opinion, I think both of these are totally fine. This is not too bad, but I think it is more conventional to call an index IDX and a value to call it val. I and v do feel a little vague, but when we're enumerating, we'll usually call it IDX anyways. So cool. Variable types. So the way this is titled, I think, could be a little bit misleading. Variables hold values. The values themselves are of a given type. So it's the value that has the type rather than the variable. So variable holds a value, value has a type. That's how I think about it. So if I did like 7, or I said x, 7, and I get the type of 7, we're going to get an integer. Class int. If I did like x equals 7 and I get the type of x, that's also going to be an int, right? So the type of 7 is an int, x equals 7, the type of x is also an int. You know, of course, it's going to be an integer no matter what number it is, as long as it's not like a float. So if I change the type that x is pointing to, if I say 4.5, then you can see it's going to change the type to a float instead of an integer. You will see this syntax used, is instance, which will give you true or false. It's it's regarded as best practice when you want to see if something is of a given type to use is instance. I don't like it. I'll just say that. I prefer to just use type. If I want to say, let's say I want to know if the type of x is an int or a float. This is what I like to do. I'll just throw the type identifiers in a tuple and then just check for membership with type. So you can see true, right? So as long as x is an int or a float, it's going to be in there. If I make it into a string, then it's going to be false, right? So to be clear, what I'm saying here is it's considered best practice to do this. Is it this? No. Sorry, like that. It's considered best practice to use is instance over to do type checking like this. But I don't agree. It's just it's a personal opinion, and I don't prefer to use as instance. I find this to be simpler and more straightforward myself. There's also an instance where this works differently. If I see, let's do this. X, I think it's if I do bool, will that work? False. Let's say int. Let's see if true is an instance of int. Yeah, okay, so if I say bool, so you can see if I have, let's just call this y equals a bool. So it's either true or false. Let's just print off y really quick. And we'll see if this Boolean, y is a Boolean, and we'll see if it's equal, if it's an instance of an integer. And it says it is, right? So true means is instance thinks this Boolean is an integer. So let's see if type has the same problem. So let's see if the type of y is an integer. And that's false, right? So this is a case where is instance actually does something really unintuitive. And to me, I just like, you'll see it when you see is instance, know that what's happening is that they're asking if the type of the first argument is a member of the one of the types specified in the second argument. You can specify multiple types by putting in a tuple, but you can do that in this approach as well. So I would just not use as an instance. I don't see a reason for that function to exist in Python, in my opinion. Maybe somebody has a really compelling case for why I should be using it, but I've never heard that case. Other than that, it is technically conventional. So this is better. Like I said, I think it's simpler. It reads very clearly, right? Like if the type of y is equal to an integer, pretty straightforward. It just uses simple equality checking or membership checking like this, and more importantly, it has more. I would say more predictable behavior than isInstance, because it's possible for isInstance to give you some odd results with Booleans. So anyways, if you're doing type checking, I recommend just using type directly. Okay. Do just want to give folks a reminder. If you're in the stream, go ahead and say hi in the thread in Slack, just so I know who's around. Help me get a sense of who's around. And the floor is still open for questions. If you have any questions, feel free to ask. Okay. So let's just go through these then. What will the following code print? X equals 1.5, x equals 3 over 2. Type of x will be an int. Oh, it wants it exactly. Let's see what's going on here. Okay, let's do this. I see. I forgot the quotes. There we go. What is the type of x at the end of this code snippet? 4 times y. So if y is a float, which it is, so that's a float. Which pattern is better for checking if x is of the type int? Well, in my opinion, it's this. I'm sure, though, that learn is looking for this. Ah, look at that. I read all the questions this time. So both of these are appropriate. Although I mean, you choose whichever one you want. If you choose the isInstance way, you're doing things the Pythonic way, but expect unexpected behavior. Just know that weird thing about Booleans and remember that you have to deal with it. If you want consistent behavior, then do it my way, which is this one. So I do have a preference, but both are technically correct. Okay. Let's see here. So this is going to get into object ID. Let's delete this. So if I do, there's another function that's useful, ID. So ID takes in a value and it gives you the ID of that value in memory. Now every time I run this, oops. Every time I run this, I'm going to get a slightly different value. And you can see, usually you can see it the best if you look at the right hand side of the number, like the last few digits are going to be different. Oftentimes the leftmost digits are going to be the same, you know, so 9475, 9471, so yeah. So they don't start changing until you get further right. So I just look at the right hand side to see if it's different. So this is just a numeric ID that is assigned every time my program runs, and I'm just running it multiple times here. Every time the program runs, this numeric ID is going to get a new numeric ID is going to get assigned to it. And this is just an integer. It's a regular old integer, essentially, or at least that's what ID returns. It returns that ID as an integer. If I do hello, right? So no matter what the value is, it's going to have an ID associated with it. And that ID will change every time we run our code, right? So if I run this again, we're going to get different IDs. So this is a useful function. This is going to sound really funny, I think, probably initially, but it's a useful function for seeing if two things in your program's memory are literally the same thing. And if you think about that sentence is, it makes it sound funny, but it's actually a very sensible thing. So there's multiple ways in which things can be the same, right? If you have, let's say, you have two phones that are, you know, were rolled off the assembly line exactly the same, or, you know, yeah, let's say exactly the same time. They both rolled off the same production line at the same time. They're both having the same parts put on them. They're both by the same make and model. They both have the same spec. They're, you know, exactly the same hardware, exactly the same software and everything, right? So you could say those phones are the same, but they're not one and the same phone, right? Like they're two different objects that occupy different points in time and space, but they are the same in that they are identical. They're separate but identical. So if I have, let's say, x equals 4 and y equals 4, and I'll print the ID. We'll say y and ID of y, and we'll do x and the ID of x. So if we look at this, right, the values are the same, and the ID is also the same, which is interesting. right? So these are not two different phones, as it were, right? These are one phone. These are one object. There is Python didn't go and like store a 4 in the program's memory and assign this ID to that 4, and then go store another 4 in the program's memory and then assign another ID to it. What it did is it assigned, or it stored one integer, 4. It did that once, and then it pointed this x and this y. It pointed these variables both at the exact same, literally the same object. So there's only one 4 in my computer's memory, and this can work because integers are what's known as immutable. We can't destroy or change an integer. We can change the integer a variable holds, right? So I could change y. Let's say I'll change y equals 5. Or let's do y equals y plus 1, which will be 5, right? And then now y has a different ID. Whoops. I'm just going to do this. Right? So now y has a different ID, but if I go back to y equals y minus 1 and print y, so y is 4 again, then you'll see y is back to having the same ID as x and the previous value of y, right? So that shows you 4 only exists in the program's memory once, one single time. And then we can point multiple variables at it. And since it's immutable, what that means is it can't change its value. It can't be destroyed. It's such a simple thing. Like, what does it mean to change a number? We wouldn't want to do that, because if we changed what it meant to be the integer 4, then we wouldn't have a 4, and what we would change it to be another integer that already exists. So why wouldn't we just use that integer? So we can't mutate that value. So therefore we can count on it staying the same, since we can't change it. So since it can stay the same, since it'll always be the same, we can just point multiple things at it, and that saves resources, right? We don't have to store multiple things and assign multiple IDs if we know, well, this thing's never going to change, and might as well just assign an ID to it. So, or assign multiple variables to the same thing, and then we can always repoint those variables at different other objects. Okay, cool. Oops. Okay. This is actually, that's funny. This is literally the example that I gave, essentially. So x equals 4 and y equals 2 squared, which is 4. And then we're seeing if the ID of x and the ID of y are the same. And that since that's literally the example that I gave where x and y were both 4, then we know. What will this print to the console? So this will print true. True or false, will x, y, and z print the same location in memory? So this is the square root of 16, which is 4. So these are both 4. So one thing that I know is that 2 squared is the integer 4. 4 is the integer 4. 16.0 to the power of 0.5 is the float 4. So well, let's just look at this. The ID of 4 and the ID of 4.0. So you can see those are different IDs. So these will not all have the same ID. And consider this small challenge this small change to the code above, true or false. So in this case, we're casting this as an int, but we're not casting the whole thing. We're making 16.0 an integer and raising that to the power of 0.5. So what happens when you mix and match floats and ints, it's fine, you can do that, but you always end up with a float. And the reason for that is even if the value could be expressed as an integer, you want operations given the same operation with the same types for its input, with like the same input signature. You want it to always give you the same type on the output just for the sake of consistency. So you wouldn't want to have an operation that, like, imagine how it would be if you had a mathematical operator that took any combination of int and float, either int int or float float or int float or float int on it for its operands. And you wouldn't want to have it sometimes give you an int back for a given one of those, and for a given one of those sometimes give you a float back. For a given combination, you want to know that its output is consistent, its output type is consistent. So in this case, we're turning 16.0 into an integer and raising it to 0.5, but we're not converting the whole thing to an integer, so that's still false. Cool. Somebody's saying, hi, I'm in, but I'm just starting it today. Well, welcome. Hope you're enjoying it so far. Happy to have you here. Feel free to reach out to me if you have any questions. If you have any questions from Learn, feel free to post in a link, and I'll be happy to take your questions on stream. And if you have any other questions, feel free to DM me and send me a direct message on Slack, and I'll be happy to answer your questions after study hall. Cool. All right. So we've got a section on function parameters. So we're getting a little bit into functions here. So if you recall, we have, let's just talk a little bit about functions. With functions, we have what I'm going to call two phases. We have the definition, and invocation. So with the definition phase, we have, this is where we define our function. Take in some value and return the value or whatever. And then the invocation is where we oops, is where we actually utilize the function. We'll put it in a print. Cool, so you can see I'm passing the argument 3 into the function. Then the argument 3 will be known by the parameter n. So n will hold the value that I passed, and then everywhere in this function that it sees n, it will plug in the value 3 for this invocation. So functions allow us to write code once and then utilize it as many times as we want. Let's actually write something useful. Let's do factorial. Factorial. Oops, I feel like I spelled that wrong. Wow. Okay. I think that's right. For I in range 2 to n plus 1. Let's do prod times gets I, and then we'll return prod. Okay. Factorial of 3, right? And then if I want to do factorial of 7, 3, 5, 4, right? So you can see I can call this factorial function and get the factorial of any number that I want, and I can do it as many times as I want. And I don't have to write this whole process out every single time I want to calculate factorial. I just write this process out once, and when I'm writing it out, when I'm defining the function, I don't know what the value is for n, right? And that's what's useful about it. It's like a variable with no value yet until I invoke it, and then I'm saying, okay, now I want you to actually perform the process, but I want you to replace n, the parameter n, with the value 3. And so this is very much like a variable, this function parameter, which is what we call the name of the input, the name portion of the identifier of the input to the function, right? So here we have the function head, the function definition, and we've got the def keyword and the name, and then inside the parentheses we get to name each one of the inputs into the function. And what we call those inputs as a category, what we call them is parameters. We call them parameters when we're defining the function. So the parameters are the name, right? So we would say n is a parameter. We would say 3 is an argument, right? An argument is what we provide when we invoke, when we call the function. I always say invoke or invocation. It's more conventional to call it a call, but I find that causes some confusion, so I always say invocation instead of call. So in the function call or in the invocation, whenever we invoke it, we pass in arguments, and arguments are specific data, right? Now we could pass in a variable, some value equals, let's say 27. So I could pass in some value. And the factorial of 27 is a very, very, very big number. You can see that. So in this case, right, like it doesn't have to be, the value itself doesn't necessarily need to be the thing passed to the function as an argument, the thing given to the function as an argument, it's just something that expresses or evaluates to a value that the function can use. So in this case, we pass some val, and some val is a variable that evaluates to its value, which is 27. So this is essentially the same thing as just passing 27. Cool. So So what will the following code return? So we have a definition and an invocation. So this is going to return, oh, this, again, I gave this example initially. This is just an identity function. So this is going to return 10. So, and I know it's going to return 10 because we have the invocation and we're passing 10 as an argument. 10 will be represented as x internally inside this function. So this just says return x, and x has the value 10 for this argument. So we'll say 10. Or for that invocation I meant. Consider this function definition and match the option below. Excuse me. Is Pythag a squared, or excuse me, so this will take in a, b, and c, and it'll return a squared plus b squared, and it'll check equality against c squared. So it'll say, this is like saying, is it true or false that the sum of a squared plus b squared is equal to c squared? And if it is, then we have a Pythagorean triangle. So let's see, a, b, c are arguments for the function. So a, b, c are parameters. Arguments are the specific data that we would plug in. Is Pythag is the name of the function, and a, b, and c are its arguments. Is Pythag is the name, okay, is Pythag is the name of the function, a, b, and c are its parameters. Wait, how are these different? I think this is the better one. Okay. Weird. Consider the code print is Pythag 345. Is Pythag is the name of the function, and 3, 4, 5 are its arguments. Yes. I'll just go with that one. Eh. I mean, that's definitely true, but all right. Is Pythag is the name of the function, and a, b, c are its parameters. Well, maybe. Is Pythag 3, 4, 5 is the argument passed to print function, and 3, 4, 5, aha, yes, there we go. 3, 4, 5 are the arguments passed to is Pythag function. Yeah. Okay. All right. So variable scope. So this has to do with using variables that are created inside and outside of functions. And if we covered classes in Premium Prep, Python classes and object-oriented programming, this would apply to that as well. But we're just going to keep this local to functions. So when I have a variable and a function, okay, so let's just work with this a little bit. So I've got this variable declared outside the function, declared, and since it's a variable, I'm initializing it with a value, right? So x is declared outside the function. If I try to access x before the function, is it accessible? Yes, it is. So x is accessible outside the function. And it's also acceptable or accessible after the function. No reason it wouldn't be. Outside the function, outside, and I'll just say and before. Outside and after. And let's see if x is accessible inside the function. Look at that. So now this is inside the function. So this is not something that you want to do. You don't want to, when you have a function, you never want to access a global variable inside the function. Imagine Python is letting you do this. Honestly, I wish this was, there are other languages that disallow this behavior. And I kind of wish Python did as well, but it doesn't. It totally just allows it. So we're going to return, let's say, x times y. And let's print this off so we can see what it's returning. So that's what we're returning. So the reason that you don't want to do this is this function is now, the way that this function works is now dependent on whatever the value of x is. So if I change the value of x, if I say x equals 200, that just changed my function, right? So see, now my function does something totally different. And you might think, oh, well, that's a cool thing that, like I could see somebody looking at this and saying like, oh, maybe you could use that. To be honest, maybe you could, but there's no point that I'm aware of where doing this actually gives you any ability to do something that you couldn't do before. There's no problem, in other words, that I've ever been aware of. There's no problem or set of problems that I'm aware of where this is necessary. So in other words, you can get away with never doing this. And the reason you should never do it is because it makes your code confusing. You now have to remember that, whatever this function is called also is controlled by some other variable that hopefully is also in scope. And, like you have to give it a value. Imagine I pull in this function that's reliant on something in the global scope called x, and I've got something in the scope that I pull it into, like I import it from somewhere. I've got something in that global scope or in that other scope called x, and I don't realize that conflict is there. Then this function is not going to do anything like what I thought it was going to do, and I'll have no idea why. And so there's this whole class of very fascinating and very, very frustrating problems that this pattern can introduce. And let me redo this pattern. I'll say don't do this. So x equals, I'll say global variable equals this. Def my function, take in y, and return y. let's just do y times x. Oh, excuse me, this is called global variable now. I'll call it x. Don't use x. Don't use a global. Don't use a global variable. Now, this is the same example, just with kind of less stuff around it. So let's do print my function, and we'll do 5. So this is going to give me 15. Oops. And if I change x, we're going to get something totally different. So I just have this random variable that has total control over how this function works. So you really want to be careful about that. Like I said, I wish this was not legal in Python. I wish Python would throw an error and tell you that you can't do this, but it totally allows you to do it, which is a little unfortunate. Python is, I think, a great language. It's one of my favorite languages to work in, but this is kind of a funny thing where I'm kind of like, well, you didn't need to make that possible. You could have made that an error, kind of prevented this bad pattern. To be clear, even though it allows you to do this, and in my opinion, it shouldn't, there's never a case to do this. There's never a time where this is actually useful. The temptation may be there if you have some data and you're like, well, I want to use that data in my function. But Clark told me I can't use it, so what do? I'm just going to use it anyways. So the way, if you have data that you want to, and you want to write a function, and you want that function to operate on that data or utilize that information in some way, that's totally fine. You can pass it in as an argument. You might be like, well, my function only takes one argument. And I would say, well, then make it take a second one. So let's just call this y and z. And then instead of doing this, we'll say it will return y times z. And then we'll just pass in x. And then x equals 7, right? So this will still give me 35. But now I have control. If I want this to be something else, the function has it on site or on board, essentially, right? Like I can, all the values that influence the outcome of this function go right here in the inputs where they belong. So that's totally fine. And if I want to pass in x, I can pass in x as an argument. So yeah, so it's not wrong to have global variables that you want to use inside your functions. It's just how they get into the function is what's important. What you want to do is you want them to come in through the front door, as it were. The parameters, or rather the arguments in the parentheses when you call the function, that's the front door. So the back door would be that you're just using it just out of the blue like this. That's the back door. So you don't want to just use it out of the blue. You want it to come in through the front door, through the registered channel in which information is meant to come into the function. Now, there are things that you use through the back door, right? So if I say def, let's just do it this way. So functions come into other functions through the back door. All right, so if I did, let's say I wanted to do like factorial, right? I don't need to pass factorial into this function. I can just def factorial, and I could just use factorial so we can say that that came in through the back door. So that's okay. That's fine. That uses the employee entrance. Functions, another, the factorial function is another employee, so it can come in through the employee entrance. And then the actual data that you're using in the function is the customers, so they have to come in through the front door. If you want to do it that way. So obviously these are going to give us giant numbers because factorials, yeah. Well, let's see. All right. So there's a few more things about variable scope that are worth talking about. So I had, back to this example, we have this global variable x, and we've already determined it's accessible outside of the function. Currently, this function is reliant on it, which isn't a good thing. But let's look at, so we know we can access x inside the function and outside the function. If there's any doubt, if Python has a choice between a parameter by the name of x and a variable by the name of x, a global variable, it'll go with the parameter. If it has a local variable by the name of x, then it'll go with the local variable, right? So another example here, we could just do x, and we have to give something for y now. So that'll be fine. So if there's ever any point where Python has a choice of whether to use a global variable or a parameter or a local variable, it'll use a parameter or a local variable first. Z. So let's look at Z here. So Z is a local variable. It's local to the function. So let's do print Z there, and we'll print it out here as well. So let's just first print it in here. So this will say Z is accessible inside the function, and I'll just say this. Z is declared inside the function, so it's a local variable. It's local to the function. So let's see what happens if I try to access it outside. So as soon as the scope of this function ends, as soon as this function is over, we're back out here in the global scope, tabbed outside of the function, tabbed all the way left. We're outside of the function. So this variable is no longer accessible. So Z is not accessible outside the function. Cool. All right, I'm gonna wrap things up there. I'm gonna paste in today's code. We're right at our normal stopping time. And I'll paste in that code. If anybody wants to reference it, it's in the Slack thread there. All right, cool. It was a little bit slow day today, but I know we had one person who's new, so welcome. Hopefully you're still with us, and hopefully you're enjoying study hall. Anybody who's watching this, feel free to send me a direct message on Slack in the DSI prep workspace in Slack, and yeah, feel free to reach out if you want help with anything. If you want to do a one-on-one mentoring session, I'm available for that. That's mostly what I do, and I'm available. I have a lot of availability these coming weeks for one-on-one meetings. So yeah, don't be a stranger, and hopefully I'll see you all around soon. Cool. You'll have a good rest of your day. Bye bye.